Okay, let's look at some problems about scientific notation. So the instructions here are to either put the number into scientific notation or take it out of scientific notation. So the ones that are already in scientific notation are number 2 and number 4, because they have this times 10 to a power part. So for the first one, we need to get it into that form. So what we're going to do is we want to move the decimal from the end. So if the decimal doesn't appear in the number, that means it's the end. We want to have it go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places and come all the way to right after the 7. So how do I do that? So I want to end up with a number that looks like this, 7.825. But somehow this needs to be the same number as the one that I started with. So the way you make this happen is to multiply 7.825. How many places did I move? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I multiply by 10 to the 10, so in other words, multiply by 10 10 times, then that would make this 7.825 get bigger and bigger and bigger and bigger and bigger until it's as big as this one. Okay? If you forget whether it's 10 to the positive 10 or negative 10, just remember 10 to the 10 is a really big number. That's like 10 times 10 times 10 times 10 times 10 times 10 times 10. And we started with a really big number, right? If it was a negative power, then it would be a small number because that would be a bunch of 1/10. I'll show you on this one what I mean. So on this one, even though it's scientific notation, it's still the same rules of exponents that you've studied in other classes. So this really means 1.34 times 10 to the negative 3. Remember, negative exponent means if it was positive exponent, like this one, it means multiply by 10 10 times. Negative exponent means unmultiply by 10 3 times. How do you unmultiply by 10? You divide by 10, or you multiply by 1/10. So 10 to the negative 3 means 1/10. Multiply by that 3 times, like this. So that is going to make the number 1.34 smaller. And every time you multiply by 1/10, you're moving the decimal place in the direction that makes the number smaller. Okay? So if I were to do 0.134, that would be the first place I would move it. And that's not far enough, right? So that's moving it one place. If I do 0.0134, I've moved it 2 places. And I'm going to need to go one more to move it 3 places. So put 2 zeros like that. And now let me just count. If I go backwards, 1, 2, 3. Yeah, moving it 3 places would put it back where it was. Okay. So for the next one, I see that I have a really small number. So I can already tell this is going to need to be scientific notation with a negative exponent. And just let me count how many 1/10ths I would need. So to get the decimal over to here, which is where I want it, right after the first non-zero digit. So I'll have to move it 1, 2, 3, 4, 5, 6, 7 times. Okay, so scientific notation always start with the first non-zero digit, which is 5, and then 0.72. And then the only question is it the positive or negative exponent? It was 1, 2, 3, 4, 5, 6, 7. It's going to need to be -7 because that's the exponent that gives me a really small number like this one. Negative exponent, small numbers. Positive exponent, big numbers. So I see looking at this one, this is a big number because 10 to the 5th is 100,000. So this is big. All right, so what you might want to do is pad this out with zeros so you have enough space to move it. So I've already got 2 spaces I can move it. I guess I need 3 more. Okay, so now I can do 1, 2, 3, 4, 5. And I started with the decimal here, so let me go ahead and copy 10 to the 5th there. And now I'll actually do the move. So moving the decimal all the way to the end, 825,000. And that's it.